Remote sensing and AI integration in wildfire management. In order to effectively manage and mitigate wildfires, it is crucial to have accurate and up-to-date information about the extent and severity of burned areas. Remote sensing and AI integration have proven to be valuable tools in mapping and assessing these burned areas. This tutorial will guide you through the process of mapping and assessing burned areas using remote sensing and AI techniques. Data acquisition. Start by acquiring satellite imagery or aerial photographs captured before and after the fire event. These images should have high spatial resolution to capture detailed information about the burned areas. Multispectral or hyperspectral imagery can provide valuable information about the spectral properties of the landscape, allowing for a more detailed analysis of burned areas. Pre-processing. Before mapping and assessing burned areas, it is important to calibrate and register the acquired imagery to ensure accurate and reliable results. Apply radiometric correction techniques, such as histogram matching or atmospheric correction, to ensure consistency and remove any unwanted noise or artifact in the imagery. Change detection. Perform pixel-wise subtraction of pre-fire and post-fire images to detect changes. This approach highlights the areas that have been altered by the fire. Establish a threshold value to distinguish burned areas from unburned vegetation and non-vegetated areas. This can be done by comparing spectral indices or reflectance values. Instead of pixel-level analysis, utilize object-based methods that consider the spatial and contextual information of the burned areas. This can provide more accurate and meaningful results. Classification. Utilize AI techniques, such as machine learning algorithms, to classify burned areas into different classes, for example, severely burned, moderately burned, unburned, based on spectral and contextual information. Extract relevant features from the satellite imagery, such as vegetation indices, for example, NV, or surface temperature, to improve classification accuracy. Validate the results by comparing the classified burned areas with ground truth data, such as field surveys or high-resolution aerial imagery. Analysis and assessment. Calculate the total area affected by the fire by aggregating the classified burned areas. Assess the severity of the fire by analyzing the characteristics of the burned areas, such as vegetation damage or soil burn severity. Evaluate the ecological consequences of the fire by analyzing the changes in biodiversity, vegetation recovery, or soil erosion patterns. Visualization and reporting. Visualize the results by creating maps that depict the extent and severity of burned areas. Use color palettes to highlight different levels of fire severity. Generate time series maps or graphs that showcase the evolution of burned areas over time. Prepare a comprehensive report summarizing the methodology, results, and implications of the mapping and assessment of burned areas. Include visuals, tables, and figures to support the findings. By integrating remote sensing and AI techniques, mapping and assessing burned areas become more accurate, efficient, and timely. This aids in effective wildfire management, providing valuable information for decision-making and resource allocation. Remember to follow ethical guidelines and obtain necessary permissions before accessing and using remote sensing data. Additionally, regularly update your knowledge on the latest remote sensing and AI technologies to stay informed and ensure the reliability of your assessments.